Okay, hi guys. So in this lecture, we'll be discussing more examples on the Beckmann rearrangement, and we'll be seeing a complex scenario wherein we get the products of one reaction consumed by the next reaction. Okay, so let's get started. So the first example is we have something like this, where we have this and NH2OH, and we get H plus, and we heat it. We get product A, and from product A again we pass it H2SO4, and we get product B. From product B again we pass H3O plus, and we get product C and D. You have to identify all the products. Okay, so A product would be something like, we'll be getting NH2OH. First, the oxygen atom would be actually attacking on the H plus, and as a result it would get OH, it will become O plus H, and it will then withdraw its double bond electron from the carbon atom, and as a result we'll be getting a carbocation, which will then be attacked by NH2, and we'll get something like this. Okay, and OH here. Next, what will happen is as a result again the lone pair of oxygen atom will again attack on H plus, and as a result we'll get something like O plus H. Okay, next what will happen is this water molecule will be leaving this carbon atom, and this nitrogen atom would be forming a double bond between itself and the carbon atom, and we'll get something like this. Obviously water molecule is removed, and we'll get something like N plus H2. Okay, next what will happen is we'll get something like this with H plus recouped back into the reaction, which was consumed in this part, it is recouped. Okay, next what will happen is we'll get something like oh, actually I forgot NH2OH actually attacked, so I forgot the OH part here. Just a second. Yeah, so NH2OH actually attacked, so we'll get something like this. Okay, NH2OH here, and we'll be getting a positive charge here, so one of the hydrogen atom would actually be recouped back. Okay, and as a result we'll be getting NHOH. Okay, so next what will happen is again the water molecule in this case would be leaving, okay, this carbon atom, and due to the formation of double bond between carbon and nitrogen atom, and we'll get a positive charge, and as a result again the removal of H plus will take place here. Okay, two hydrogen atoms are again recouped into the reaction, and two were obviously taken into the reaction, hence the number of H plus taken into the reaction were recouped back into the reaction. Okay, and we get something like this. Okay, so we get a ketoxime. Okay, so this is the product A. So now what will happen on this ketoxime is, on reacting with H2SO4 we'll get something like the primary amide. Okay, this would be the product B, and on hydrolysis what will we be getting? On hydrolysis we'll be getting something like obviously let us actually react the water molecule before seeing it. So the OH would be actually first attacking on this carbon atom, as a result we'll be getting something like this, or rather, and then oxygen atom will take back its electron, we'll get something like bond electrons, we'll get something like O plus H and H here, we'll get NH and CS3 here. Okay, next what will happen is, obviously H plus will be getting removed, this O minus will again form a bond, and N minus will be getting removed. We'll be getting something like acetic acid, and obviously we'll get something like N minus HCS3, which will again attack on the water molecule to attach NH2 over itself. So we'll be getting a amine, okay, a primary amine, and we'll be getting carboxylic acid as product C and product D, acetic acid. Okay, so let's discuss another example. So here we are just twisting the above reaction and we are passing a product A with NH2OH, we get a product B. On passing H2SO4 on product B, we get product C. On hydrolyzing this product C, we actually get these two products, which are PHCH2, rather CO2H, and we also get CH3NH2. Okay, so what would be the product C? We are just going from back or in reverse direction. What would be the product C? Product C would be nothing but a amide, something like this, because in amide on hydrolysis OH will come here, H will come here, and it will give PHCH2OH from this part, and from this part it will give rather NH only, NH2CH3. okay, so C would be this, and what would be the product B, which on having Beckmann rearrangement or in acidic medium would give this amide. So it would be nothing but we'll be having something like this product. This would be the ketoxime. Okay, so this would be the product B. Okay, and what should be product A, which should be acting with NH2OH to get to product B. So the product C would be something like we would have a ketone like this. This would be product C. Okay, let's discuss another example where we have something like a ketone. Okay, on this we react with NH2OH in acidic medium, we get to a product A, and when on reaction with H2SO4 we get a product B. So you have to identify product A and B. So product A would be nothing but we will be getting something like this ketoxime. How? Obviously H plus would be attacked by oxygen molecule, and as a result in the second step, or in the first step rather, we'll be getting something like this NH2OH attached here. Why? Because this will be getting a partially positive charge. Okay, and then NH2OH will be attacking on this carbon atom. As a result, we'll be getting something like this. Again the OH will again attack on the H plus, and as a result we'll be leaving this carbon atom. Okay, and already the N has a positive charge, okay, because of bond formation with the carbon atom. Okay, in the next step what will happen is we will get something like again positive charge here, NHOH. Again what will happen is it will again donate its lone pair to the carbon atom or the carbocation, and this group would be leaving as a H plus. Okay, so this will be leaving as H plus, and this will also be leaving as H plus, and finally we will have something like a ketoxime. This will be product A, and this on reaction with again H2SO4 should result in a secondary amide. Okay, so what will actually happen here is there is one of the two carbon atoms has to migrate to N, so we'll get something like we have something like this carbon atom on migrating on this nitrogen atom, we'll get something like, we'll be getting something like this carbon atom would actually migrating on this nitrogen atom, and as a result we'll be getting something like this will be attached to nitrogen atom, and we'll be getting something like this. A 7-membered ring. Okay, 1 2 3 4 5 6 and 7. Okay, and obviously C double bond O here and NH here. Okay, so this will be the final product which we will be getting after tautomerism. Okay, so how is this? So this was the carbon atom which was attached to here. Okay, and we are getting this carbon atom attached to this nitrogen atom, and as a result 7-member ring was formed. Okay, let's look at another example where we have something like this. Lone pairs here, and we are reacting it in H2SO4. What will happen is, first we'll be getting something like we have obviously double this ketoxime ring from this ketoxime from this ketoxime molecule. What will be happening is one of the carbon atom would be migrating to the nitrogen atom. Okay, and as a result we'll be getting a 6-membered ring. Okay, so what we will see is we'll be getting something like between this carbon atom and this carbon atom we'll have tautomerism. Okay, OH will be getting attached here, double bond here. Okay, so for clarity you can assume that this bond is actually migrating to this nitrogen atom. Okay, and we'll get this is the second, let me label it as the carbon 2 and this as carbon 1. So carbon 1 is here. Okay, carbon 2 is here. So I think carbon 2 is not here. Carbon 2 would be attached to the nitrogen atom. We'll be getting something like this as the carbon 2, and then 3 4. Okay, three, 4, 5. I forgot the fifth one here. So 3 4 5. Okay, now tautomerism would happen. As a result we'll be getting something like this as the final product. Okay, so with this we come to an end of this lecture. From the next lecture onwards we'll be starting off with alcohols and ethers. Okay, so till then, good luck and goodbye.